I want to talk about something really interesting with the solar sail. Here I have set up a situation where the solar sail is at the same orbit as the Earth, but on the opposite side of the Sun. The solar sail will just stay in the same relative position at this point because it's pointed directly perpendicular to the Sun, so there's no pressure being exerted on the solar sail. But I could also arrange to fly the solar sail at the same position, but with the solar sail directly facing at the Sun. And if I were to do this, I could orbit at the same radius as the Earth, but it seems like I'd be going a different speed. And this is kind of an interesting situation to set up. So what I'm going to do is adjust the solar sail to be pointed directly at the Sun, which is going to change the future trajectory shown in the gray line on the right hand side with respect to the orbit that it's on. And so you can see the Sun is pushing the solar sail farther out. But this only happens at one spot, and it'll form an eccentric orbit that's kind of centered at the spot where I initiated that maneuver. Now I can adjust the angle of the sail to bring it back down to be in line so that it's at the same radius as the Earth again. But since it did this adjustment, the sail will be going faster than the Earth. Actually, no, I think it'll be going slower than the Earth a little bit in the orbit, and so the Earth will slowly be catching up to the sail. In the center of the screen, I have what's calculated to be the distance in astronomical units. So you can see the sail is approximately 1 AU from the Sun, which is what the Earth is, and then the relative speed is the speed that it's traveling at that orbit with regards to the Earth at that same orbit. And so I need to fly the sail in such a way that I can try to get that distance to be 1.0 AU consistently around to try to make it as relatively circular as possible. But what's interesting is when I do that, the relative speed of the solar sail doesn't come out to be 1.0. It comes out to be about 0.97 or something. And so it's going a little bit slower than the Earth is. So having the solar sail try to push the sail makes it actually go slower around the orbit, which is really kind of interesting way to fly a solar sail. And this is a little bit unexpected, but I think it's interesting, and I think that this has potential applications for interesting missions of real solar sails maybe, and certainly in this simulation. So if I set the sail exactly to 90 now, it's pretty close to the Earth-Sun distance. The average is about 1.0. I haven't made it perfectly circular, but the speed is about 97% the speed. And so what will happen is if I speed up the simulation, the Earth should be catching up, and you can see that in the left-hand window where the cursor is. You can see the Earth is slowly catching up in its apparent position to the solar sail. Now this takes many years, since it's only about a 3% difference. So after 15 or 16 years, the Earth does catch up to the solar sail and eventually passes it. And I think it's knocked the solar sail out of its orbit a little bit due to the gravity. So that's an interesting result. That's a little bit unexpected.